I'm looking at the Unit 4 review problem 41. That's about pregnancy tests. So when I read over this problem the first time, suppose that 70% of women who suspect they may be pregnant and purchase an in-home pregnancy test are actually pregnant. So it looks like we're dealing with two things: whether or not somebody's pregnant and whether or not the test works. So I don't see any information about like probability of both, or so I think what I better do is try to use a tree. Okay, so the first thing I'm going to do is just sort of say, well, look, they're either pregnant or they're not pregnant. So 70% of the women that buy the test are pregnant, and then the others are not. Okay, so now the test is either going to be positive, so that means it's going to detect that she's pregnant, so that's 0.98. But there's a chance, 2% chance, that the test says she's not pregnant when she really is. Okay, and then let's see. So here, positive would indicate that she's pregnant, okay, which is false, right? Because she's not pregnant. So that would be 2% of the time. 2% of the time it's wrong. And here, this would be 98 because it's accurate, right? She's not pregnant and the test says negative, you're not pregnant. Okay, so that's the tree. And of course these branches can be labeled. Like this should be. Alright, so now let's look at what's the probability that a woman whose test indicates that she is pregnant actually is. So what's the probability that she's pregnant given that the test was positive? Okay, so that's a conditional probability. So remember, we would use the probability of A given B is equal to the probability of both, the probability of A and B occurring, divided by the probability of the given, B. So here, what's the probability of both? Probability that she's pregnant and it's positive, divided by the probability that the test was positive. Okay, so pregnant and positive is right here, so that's going to be 0.7 times 0.98. And then positive, though, it could be there's a positive test and there's a positive test. So we're going to have to add those. Remember that these all add up to 1.00. So you would add these. So that would be 0.7 times 0.98 plus 0.3, right? 0.3 times 0.02. Okay, so I get 0.686 divided by 0.686 plus, it's not much, but it factors in. Okay, so about 99.1% of the time, when the test says it's positive, the woman is actually pregnant. So that's pretty good. That's pretty good accuracy in general. Okay, so that's how you do that problem. The key is to use a tree and to recognize that it's a conditional probability. Good luck.